Welcome back. Today we'll be talking about some simple consequences of the probability axioms. So today we'll be talking about disjoint events, three disjoint events, and we'll be using that consequence to apply that into one practical example where it has many finite k elements, and we use that disjoint application to that example. Now we'll start focusing on the first disjoint event, and in this case we have three sets in a sample space. At this point I'm going to draw the sample space, and within this sample space there are three events or sets: A, B and C. Now what this says is that what we need to prove is that probability of union of A, B and C is equal to probability of A plus probability of B plus probability of C. Earlier in our previous session, we only proved with additive axiom for two disjoint set, but here in our case we have three. How do we apply our additive axiom to three events? The first step is to form one set by taking union of event A and B. So we have two sets now, union A union B and C. Since A union B and C are two disjoint events, then we can say that since A union B are two disjoint events, we can say that probability of A union B is equal to probability of C by additive theorem axiom. By additive axiom. Similarly, we can use additive axiom again to break down A union B to A probability of A plus probability of B and the remaining probability of C. Thus, we are able to prove that probability of A union B union C is equal to probability of A plus probability of B plus probability of C. It is proved. This can be done for 3 or more events. Also, we can use induction to prove that if we have a set A1 through AK which are disjoint, then we can say that probability of this probability of set with the union A union through AK, probability of set which is made by union of A through K is equal to individual probability of each of those sets. That is probability of A plus probability of AK. We can say that by induction. This applies to finite set of disjoint events. Now we're going to turn our focus to next practical application of what we just proved. It says that what we need to prove is, or what we need to find out is, what is the result of probability of events S1 through Sk which are disjoint and finite in a sample space. We need to find that out. So how do we do this? Let's take a sample space and it has a set with k elements. It has a sample space and it is a set of k elements. That's the context. K elements, that is the context. Now we have to assume that these all elements are a set of its own. So we'll assume that these all elements are set of its own. Now we can write this as probability of S1, S2, S3 through Sk as probability of individual sets. S1 union of individual sets. What we have is, since these elements are set of its own, we can write as a union of individual sets because these are distinct sets and there is no overlap between them. As you already know that since they are distinct and they are disjoint and hence disjoint, we can use the additivity axiom on top of that, which will give us the next result, which will give us that the above expression equals to probability of S1 plus probability of S2 up to probability of Sk. That means probability of S1 set S1 union set S2 up to set Sk equal to probability of set S1 plus probability of set S2 plus probability of set up to Sk because of additive axiom which we proved earlier. Now we can take next step to further simplify the notation. Instead of saying set 1, we can just simply write S1, and for set S2 we can just simply write S2, and so on up to Sk. Now we have proved that probability of set with elements S1 through Sk is equal to probability of S1, probability of S2, probability up to Sk. Finally, let me quickly summarize what we discussed today. We discussed about proving for three disjoint events that if those are three disjoint events, we can prove that probability of union of A, B, and C, which are disjoint, is equal to probability of A plus probability of B, probability of C. This can be applied to more than three events. And using induction, we can also say that if A through K are disjoint, we can say that probability of union of A through K is equal to probability of A plus probability of A2 plus probability A3 up to probability of AK. And we use what we proved earlier to apply that to what happens when we calculate probability of a union, a probability of a set which had k elements from S1 through Sk, and what we get as a result is we can prove out that it is equal to probability of S1 plus probability S2 up to probability Sk. Thank you so much.